Hello my schoolers, you are welcome to my school YouTube channel and my name is Frank. In today's video we shall be tackling JAMB CBT physics past question for the year 2007. So do not get anywhere, relax, and I will be right back. You are welcome back to my school YouTube channel. In today's video, we shall be solving question 1 to 25. So let's begin with question 1. The unit of moment of a couple can be expressed in... Okay, so basically what you need to know here is just the formula for calculating the moment of a couple. Okay, so the formula for calculating the moment of a couple is force times perpendicular distance, right? And the unit of force is Newton and the unit of perpendicular distance is meter. So if you put them together, that will give us Newton meter. Okay, so that makes option C the correct answer to this question. Question 2. A gramophone record takes 5 seconds to reach its constant angular velocity of 4 pi radian per second from rest. Find its constant angular acceleration. So let's move over to the board to provide answer to this question. So in this question, we are required to calculate or find the constant angular acceleration of the gramophone record. Okay, so angular acceleration, okay, is equals to change in angular velocity all over change in time, right? So the change here stands for final angular velocity minus initial angular velocity all over time. Okay, so here we're only given the final angular velocity, so that means the initial velocity is 0, so that we'll be having 4 pi, okay, minus 0 all over 5, right? So that we'll be having 4 pi all over 5. So if we divide, we'll be having 0.8 pi. So, and remember we are calculating for angular acceleration, so that will be 0.8 pi radian per second square. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option B, 0.8 pi radian per second square. Question 3. A car of mass 1500 kilogram goes round a circular curve of radius 50 meters at a speed of 40 meters per second. The magnitude of the centripetal force on the car is... So let's return back to the board to provide answer to this question. So remember that centripetal force Fc can be calculated by using the formula m times v squared all over r. Okay, so of course we are using this formula depending on the parameters that are given to us in the question. So in this question we are given mass, we are given radius, and we are given velocity. Okay, so that is why this is the most suitable one, right? So let's substitute the values that are given to us. So here our mass is 1500 times the velocity, which is given to us to be equals to 40. So we'll be having 40 times 40, then divided by the radius, which is 50. Okay, so 50 here is 1, and 50 here will be equals to 30, right? So if we multiply 30 by 40 and by 40, that will be equals to 48,000, right? 48,000 Newton. But if you look at the options carefully, you discover that they are given to us in standard form. So there is need for us to write this value in standard form. So if we write this value in standard form, we're having 4.8 times 10 raised to power 4 Newton. Okay, so I actually counted from here 1, 2, 3, 4. Okay, so that is why our final answer is 4.8 times 10 raised to power 4 Newton. So let's return back to the screen to pick the correct answer to this question, and that is option A. Question 4. Two pairs of masses 5.0 kg and 10.0 kg are 0.3 meters apart. Calculate the force of attraction between them. Then we are asked to take gravitational constant to be equals to 6.67 times 10 raised to power minus 11 Newton meter square per kilogram square. So let's move over to the board to provide answer to this question. So in this question, we are asked to calculate for force of attraction between the two masses, okay, which is Fg is equals to G m1 m2 all over r square. Okay, where r here stands for the distance between the two masses, while m1 here is the first mass, m2 is the second mass of the body. Okay, so if we substitute our value, Fg, which is the force of attraction between the two masses, will be equals to 6.67 times 10 raised to power minus 11, then times 5, then times 10, divided by 0.3 in bracket square. Okay, so here we'll still be having 6.67, then times 10 raised to power minus 11, then times 50, then divided by 0.009. Okay, so this 0.009, we put it in standard form, so that we'll be having 6.67 times 10 raised to power minus 11 times 50 all over 9 times 10 raised to power minus 2. Okay, we'll actually move 1, 2, 3. 9. Okay, this is supposed to be 0.9. So if we put this in standard form, we're having 9 times 10 raised to power minus 2. Okay, so 9 here is going to be equals to 1. So 9 here will give us something like 5.56. So let's have it like that. So we'll multiply these two first so that we can apply the law of indices. Okay, so if we multiply 5.56 by 6.67, we'll be having 37.085, maybe 200. Okay, then times 10 raised to power. So let's apply the laws of indices. So if we apply the law of indices here, we'll be having minus 11, then the minus and this minus is going to change to plus, so you'll be having plus 2. Okay, so that at the end of the day we're now having 37.0852 times 10 raised to power, of course, minus 11 plus 2, that will be minus 9. Okay, so but if you look at this is not in standard form, so let's put this in standard form. So we simply move these ones, okay, and take this to maybe let's say 1 decimal, 2 decimal places, so that at the end of the day we'll be having 3.71 times 10 raised to power minus 8 Newton. Okay, so the force of attraction between the two masses is equals to 3.71 times 10 raised to power minus 8 Newton. So let's move over to the screen to pick the correct answer to this question, and that is option B, 3.71 times 10 raised to power minus 8 newtons. Question 5. A machine has a velocity ratio of 4. If it requires 800 Newton to overcome a load of 1,600 Newton, what is the efficiency of the machine? So let's move over to the board to provide answer to this question. Now remember that efficiency of a machine is calculated by using the formula. Of course, this is one of the formula, okay? So this also depends on the parameter that is given to you. So it's given as mechanical advantage all over velocity ratio times 100%. Okay, so here we know that mechanical advantage is equals to load all over effort. So in this case we'll be having 1,600 divided by 800, so this will be equals to 2. Okay, so now that we know the mechanical advantage, let's just put it here and continue with our calculation. So efficiency of machine in this case now becomes 2 all over 4 times 100%. Okay, so 2 here is 1, 2 here is 2, 2 here is 1, and 2 here is 50. Okay, so that at the end of the day the efficiency of the machine is equals to 50%. So let's return back to the screen to pick the correct answer to this question, and that is option B, 50%. Question 6. A reservoir 500 meters deep is filled with a fluid of density 850 kg per meter cube. If the atmospheric pressure is 1.05 times 10 raised to power 5 Newton per meter square, the pressure at the bottom of the reservoir is, so here we are asked to take acceleration due to gravity to be equals to 10 meters per second square. So let's move over to the board to provide answer to this question. So to actually calculate for the pressure at the bottom of the reservoir, okay, so the pressure at the bottom of the reservoir is actually equal to the sum of the atmospheric pressure then plus the pressure due to the height, okay, or depth of the fluid. Okay, so in this case pressure at the bottom of the reservoir is equals to P, which is the pressure, atmospheric pressure, then plus pressure due to the height, okay, of the fluid. So here we'll be using, of course, that pressure. Remember that we can calculate pressure using the formula density times height times acceleration due to gravity. Okay, so basically that's what we'll be using here. Okay, so density times height times acceleration due to gravity. Okay, so if we substitute the values that are given to us, here we'll be having 1.05 times 10 raised to power 5, then plus, so here we'll be having 850 times the height, which is 500, then times acceleration due to gravity, which they ask us to take to be equal to 10. Okay, so if we multiply this together, here we'll be having 1.05 times 10 raised to power 5, then plus, so if we multiply these three together, we'll be having 4,250,000. Okay, of course, for us to add these two together, either we put this in standard form or we write this in ordinary form. Okay, so I think I prefer we put this in standard form to be easier that way. So here we'll be having 1.05 times 10 raised to power 5, then plus, so if we put this in standard form, we'll be having 4.25 times 10 raised to power 6. Okay, now but if you look at this, since we are adding in standard form, right, the power of both numbers must be the same. So if you look at here, the power here is 5 and the power here is 6. So we'll either move this one to 6 or we'll move this one to 5. Okay, so we can reduce this to 5 so that the two powers can be equal, or we can move this to 6 so that the two powers can be equal. So let's move this to 6. So for us to move this to 6, just for us to move our decimal point one place to our left. Okay, so but remember, when you move a decimal point one place to your left, then you are going to add extra one here. So we'll be having 0.105 times 10 raised to power 6, then plus 4.25 times 10 raised to power 6. Now we can now add. So we are going to add 0.105 to 4.25. Okay, so let's do it here. 4.25 plus 0.105. So at the end of the day, we're having 4.355. Okay, so this will be equals to 4.355 times 10 raised to power 6. Okay, so you just take one of these. Okay, so if we are to simplify this further, maybe let's take this to two decimal places, then we'll be having 4.36 times 10 raised to power 6. Of course, we are calculating about pressure, right? So pressure will be Newton per meter squared, sorry. So this is the pressure at the bottom of the reservoir, okay? So let's return back to the screen to pick the correct answer to this question, and that will be option B, 4.36 times 10 raised to power 6 Newton per meter squared. Question 7. A piece of iron weighs 250 Newton in air and 200 Newton in a liquid of density 1000 kilogram per meters cube. The volume of the iron is, so let's move over to the board to provide answer to this question. So first of all, for this question, we are to calculate for upthrust. Okay, and another word for upthrust is the same thing as buoyant force. Okay, so upthrust in this case will be equals to weight of the iron in air minus the weight of the iron in liquid. Okay, so in this case, we'll be having 250 minus 200, and that will be equals to 50 Newton. Okay, but remember that upthrust is also equals to density times volume, okay, times acceleration due to gravity. Okay, so since our upthrust is equals to 50, so we can have our 50 here, right? So this will be equals to 1000. Okay, times, of course, here the volume here, the V here stands for the volume of the liquid displayed. Okay, so we have V here then times 10. Okay, for our acceleration due to gravity. Now, since we are calculating for the volume of liquid or fluid display, so we'll be having V to be equals to 50 divided by 10,000. Okay, so divided by 10,000, so 0 will cancel 0. So that if we divide 5 by 1000, we'll be having 5 times 10 raised to power minus 3 meter cube. Okay, now remember, this volume is actually the volume of the fluid display, and the volume of the fluid display, according to Archimedes' principle, is equal to the volume of the object. Okay, so in this case, the volume of the iron is equals to 5 times 10 raised to power minus 3 meters cube. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 5.0 times 10 raised to power minus 3 meter cube. Question 8. A clinical thermometer is different from other mercury in glass thermometers owing to A, the constriction on its stem, B, the grade of mercury used in it, C, its long stem, D, its wide range of temperatures. So the answer to this question is option A, the concentration on its stem. So a clinical thermometer is different from other mercury in glass thermometer owing to the concentration on its step. So the importance of this concentration on its step is just to prevent the mercury for returning back or for dropping immediately back into the bulb once the thermometer is removed from the patient. Okay, so that makes option A the correct answer to this question. Question 9. I use a liquid with a high melting point. I use a liquid of high volume expansivity. I use a capillary tube of large diameter. Which of the above best describes how the sensitivity of a liquid in glass thermometer can be enhanced? Okay, to enhance the sensitivity of a liquid in glass thermometer, basically you need a liquid with a low melting point, and you also need a capillary tube of small diameter. Okay, and you need to use a liquid of high volume expansivity. Okay, so that means I is invalid. I is invalid. So the only valid option here is I. Use a liquid of high volume expansivity. Okay, and this enhances the thermometer's expansivity, okay, by allowing larger expansion or contraction of the liquid in response to temperature change. Okay, so that makes option B, I the answer to this question. Do you know that you can take practice question with our JAMB simulated CBT past questions? All you need to do is to click on the link in the description below, and that will take you to Myschool website. There you will need to download Myschool mobile app for your Android devices and Myschool software for your laptops and computers. Please go ahead and start practicing. Moving on to question 10. 2 kilograms of water is heated with a heating coil which draws 3.5 amperes from a 200 volts mains for 2 minutes. What is the increase in temperature of the water? Specific heat capacity of water, we are asked to take it to be equals to 4,200 joules per kilogram per Kelvin. So let's move over to the board to provide answer to this question. So basically, we need to calculate for the electrical energy, okay, and that electrical energy will be equal to, of course, the electrical energy H is given as IVT, okay, and this is based on the parameters that are given to us in the question, okay, and this will be equal to what will be equal to the energy, okay, that was used to heat the water, which is MC, then change in temperature. Okay, where M here stands for the mass of the water, C here stands for the specific heat capacity of the water, Y, delta, and theta here stand for the increase in temperature or change in temperature. Okay, but remember that our time is given to us in minutes, so we have to convert it to second, but we are going to do here, okay, and we are going to do it here. So to simply do that, it's just for us to multiply the 2 by 60, okay, and that will convert the time in minutes to seconds. So let's face in the values that are given to us. So I, which stand for current, given to us to be 3.5, then times the voltage is given to us to be equals to 200 volts, then times time, which is given to us to be 2 minutes. So we have to convert it to seconds by multiplying by 60, okay, and all of this will be equals to the mass of the water, which is 2, then times specific heat capacity of the water, which is 4,200, then times the change in temperature, okay, or the increase in temperature, which we are actually calculating for, okay. So 2 can cancel out 2 here, right? So 2 zeros can take out these 2 zeros. So if we multiply these 2, that will be equals to 7, right? So this 7 here, we also divide this to give us 6, okay? So 6 here will give us 1, and 6 here will give us 10, okay? So we can say that the increase in temperature is equals to 10 degrees, okay? So let's return back to the screen to pick the correct answer to this question, and that is option D, 10 degrees Celsius. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 11. I increase the melting point of the liquid II, increase the boiling point of the liquid. III, decrease the melting point of the liquid. IV, decrease the boiling point of the liquid. Which of the statements above about the effect on increase in pressure in a liquid are correct? Okay, so let us analyze this one after the other. So first of all, let's talk about the effect of increase in pressure on boiling point. So generally, an increase in pressure, okay, will actually lead to increase in boiling point. So let's settle down first, okay? So that means our II is correct. Increase in pressure will lead to increase in the boiling point of the liquid. Okay, now, but if you analyze the other options, okay, where they are talking about the melting point of the liquid, okay, what you must note here is that for a pure substance, the melting point and the freezing point is the same. Okay, for example, let's take mercury. The melting point of mercury is approximately minus 37 degrees Celsius, and the same thing with the freezing point, right? But then analyzing this carefully, they are talking about liquid, and take note, liquid does not have a melting point. It's only a solid that melts, right? It's only a solid that melts. So if we are to analyze this, generally an increase in pressure, okay, will actually lead to an increase in the melting point of most substances. Okay, so this is how we are going to analyze this. Now, for us to actually get the effect of increase in pressure on substances, we are going to analyze it this way. Now, for substances that are in their liquid phase, okay, for substances that the volume of their liquid phase is greater than the volume of the solid phase, for such substances, an increase in pressure, okay, will lead to an increase in their melting point. While for substances in their liquid phase, in which their volume is less in the liquid phase than in the solid phase, an increase in pressure will lead to an increase in boiling point. So for this question, we'll be assuming that they're actually referring to ice. So for ice, an increase in pressure, okay, will actually lead to a decrease in its melting point. And the reason for that is because the ice in its liquid phase is water. So in that case, the volume is less than when it is in the solid phase, which is ice. Okay, so that is what we are assuming for this question. So in that case, we'll be taking we'll be taking yes, II and III as the correct answer to this question. Okay, and that makes option C the correct answer to this question. II and III only. And the reason for that is because the question is not specific, okay, per se. They are not talking about a particular substance in quotes, so it's just like a general question. So we just assume that maybe, okay, for the melting point they are talking about ice, while for the boiling point they are talking about water. Okay, so that's why we choose option C as the correct answer to this question. Question 12. I, mass. II, density. III, temperature. IV, nature of substance. Which of the above affect diffusion? Okay, so these are the options that are provided. So for this question, the correct answer to this question is option D. III, and IV, they all have effect on diffusion. Okay, so let's analyze it one after the other. For I, mass, okay, remember that mass is related to weight. Okay, so let's say the heavier the weight of a substance, then the slower the rate of diffusion of that substance. Then let's also talk about density. Okay, the rate of diffusion is inversely proportional to the square root of density. Okay, so that means the denser the substance, the lower or the slower the rate of diffusion of that substance. Okay, then an increase in temperature definitely will lead to an increase in the rate of diffusion of a substance, right? Then for IV, nature of substance. So we don't know the nature of the substance we are talking about, whether it's solid, whether it's liquid, whether it's gas. Okay, but remember that the rate of diffusion is highest, okay, in gases than in liquid and in solid. So everything listed here has effect on the rate of diffusion. So that makes option D the correct answer to this question. Question 13. The blade of a hoe feels colder to touch in the morning than the wooden handle because the A, handle is a better conductor of heat than blade. B, handle contains stored energy in form of heat. C, blade is a better conductor of heat than the handle. The blade is placed at a lower temperature than the heat. Okay, so the answer to this question is option C. The blade is a better conductor of heat than the handle. Okay, so once the blade is handled, the blade will quickly draw heat away from the hand, okay, making it feel colder to touch than the wooden handle, which is a poor conductor. Okay, so that makes option C the correct answer to this question. Blade is a better conductor of heat than the handle. Question 14. They should be identical. They should originate from the same source. They should be coherent. They should be monochromatic. From the above statements, the condition for two waves to interfere are, so let's analyze them one after the other. So one of the conditions is that they should be identical. So if we say identical here, we mean they should have the same frequency, they should have the same wavelengths, they should have the same amplitude, they should also have the same phase. Okay, they should be in the same phase, right? Although they may have different amplitude, okay, but the most important condition here is that they should have the same frequency and wavelength. Okay, so I is required, right? While for they should originate from the same source. That is not necessary. That is not necessarily a required condition for interference to occur. Okay, the two waves can originate from different sources provided the two waves are coherent. Okay, I is not a necessary strict condition for interference to occur. So the two waves can originate from the same source. They can as well originate from different sources. But the most important thing is that the two waves must be coherent. Okay, so for they should be coherent. Yes, the two waves should be coherent. Okay, because when the two waves are coherent, that will help them to maintain a constant phase relationship. So is required. Then they should be monochromatic. Yes, they should be monochromatic, meaning that both waves should have the same wavelength. Okay, so the answer to this question is I, and IV, and that makes option C. Okay, no, that makes option B the correct answer to this question. That is, they should be identical. Then they should be coherent. Then IV, they should be monochromatic. Okay, so that makes option B the correct answer to this question. Question 15. In a large telecommunications auditorium, perforated absorbent materials are used to line the ceiling so as to A. Increase the reverberation of sound in the hall, B. Increase the amount of echo in the hall, C. Reduce the height of the ceiling from the floor, D. Reduce the reverberation of sound in the hall. So the answer to this question is option D. Reduce the reverberation of sound in the hall. So in a large telecommunication auditorium, perforated absorbent materials are used to line the ceiling in order to reduce the effect of multiple reflection of sound known as reverberation. Okay, so that makes option D the correct answer to this question. Reduce the reverberation of sound in the hall. Question 16. The phenomenon of light bending around an obstacle is A. Diffraction, B. Refraction, C. Reflection, and D. Polarization. So the answer to this question is option A. Diffraction. So diffraction is the phenomenon of light bending around an obstacle. Okay, so when we talk about option B, which is refraction has to do with the change in direction of light wave as it crosses or passes from one medium to another due to change in speed. Okay, while reflection has to do with the bouncing back, okay, of light waves when it hits a reflective surface such as mirror. Okay, while option D, polarization, has to do with the orientation of light wave in a specific direction. But remember, the answer to this question is diffraction, which is the phenomenon of light bending around an obstacle. Question 17. The instrument used by designers to obtain different color patterns is called A. Periscope. Okay, so periscope is an instrument for observing over, around, or through an obstacle which is prevented by direct line of sight. Okay, so that is not the answer to this question. While we have option B, sextant. So sextant is normally used by sailors, and they use it to calculate the angle, or using determining the angle between the horizon and a celestial body such as the moon or the sun. Okay, while we have option C, episcope. Okay, so an episcope is an instrument that projects an enlarged image of an opaque object, while we have the kaleidoscope. So the answer to this question is actually kaleidoscope, because kaleidoscope is an optical instrument that creates patterns and design by reflecting light through colored materials. Okay, so the instrument used by designers to obtain different color patterns is called kaleidoscope, and that makes option D the correct answer to this question. Question 18. A glass plate 0.9 centimeters thick has a reflective index of 1.50. How long does it take for a pulse of light to pass through the plate? So we are asked to take C, which is the speed of light in vacuum, to be equals to 3.0 times 10 raised to power 8 meter per second. So let's move over to the board to provide answer to this question. So first of all, we must not forget that speed, okay, is equals to distance all over time. So since we are looking for time, we can make it the subject of formula here, so that time is equals to distance all over speed. Okay, but the speed here actually represents the speed of light in the material, right? So for us to get the speed of light in the material, we use V is equals to C all over N. Okay, where V here stand for the speed of light in the material, this C here stand for speed of light in vacuum, and N here stand for the refractive index of the material. Okay, so if we substitute the values that are given to us, we'll be having 3.0 times 10 raised to power 8, then divided by 1.50. Okay, so if we should divide 3 divided by 1.50, that will be equals to 2. So you'll be having 2 times 10 raised to power 8 meter per second. Okay, so now our distance here actually represents the thickness of the plate. So but for this thickness of plate, we have to convert it to meters by simply dividing 0.9 centimeter by 100. So if we do that, we'll be having 0.009 meter. Okay, so we just substitute here since we are looking for time. So T is equals to 0.009 divided by the speed, which is 2 times 10 raised to power 8. Okay, so let's put this in standard form so that our division can be easier. Okay, so if we put this in standard form, we're having 1 to 3. So we'll be having 9 times 10 raised to power minus 3 divided by 2 times 10 raised to power 8. Okay, so if we divide 2 here is 1, 2 here will give us 4.5. So if we apply our law of indices, we'll be having minus 3, then minus 8. So minus 3 minus 8, that will be equals to minus 11. So that the time is equals to 4.5 times 10 raised to power minus 11 seconds. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option A, 4.5 times 10 raised to power minus 11 seconds. Question 19. When an object is placed between the principal focus and the optical center of a convex lens, it could be used as a, so option A we have simple microscope, option B we have reflecting lenses, option C we have compound microscope, and option D we have a projector. Okay, so when an object is placed between the principal focus and the optical center of a convex lens, it could be used as a simple microscope. Okay, so a simple microscope consists of a single convex lens that is used to amplify small objects. Okay, so if we look at option C, compound microscope actually uses 2 or more lenses. Okay, while option D, projector, we know that projector is an instrument or a device that is used to project an object on a surface, onto a surface, using light and 1 or more lenses. Okay, but the answer to this question is option A, simple microscope. Do you have any question to ask? If yes, please click on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our army of solution providers will provide answer to all your questions within a short period of time. Moving on to question 20. The production of pure spectrum could easily be achieved using A, glass prism with a pin, B, triangular prism with two convex lenses, C, triangular prism only, and D, triangular prism with two concave lenses. Okay, so what do we mean by pure spectrum? So a pure spectrum is one in which the colors are distinct from one another. Okay, that is, the colors are separated from one another. To achieve the production of a pure spectrum, we simply need two converging lenses, okay, or convex lenses. We need a triangular prism and a slit, okay, and a narrow slit. Now, the essence of the narrow slit is to prevent the chances of overlapping of colors, okay. But if you check these options very well, narrow slit is not listed. So the closest one is option B. Why? Because in the production of pure spectrum, we could achieve it by using a triangular prism and two convex lenses or converging lenses, okay. Convex and converging lens are the same, so that makes option B the correct answer to this question. Do you have better steps or better solution to any of these questions? If yes, go to the comment section below to comment the question number and the solution you wish to share. Question 21. A charge 50 microcoulomb has electric field strength of 360 Newton per coulomb at a certain point. The electric field strength due to another charge, 120 microcoulomb, kept at the same distance apart and in the same medium is. So let's move over to the board to provide answer to this question. So based on the last statement that was made in the question, we are told that at the same distance apart and in the same medium. Okay, so that means the distance and the medium is constant. So due to that fact, we can actually calculate for the electric field strength, okay, due to Q2. And we are going to be using the fact that electric field strength is proportional to charge, right? So E1 is equals to Q1. So that E2 is also equal to Q2. So since we are looking for E2, we can make it the subject of formula, okay, by simply cross multiplying. So we'll be having E2 to be equals to E1 times Q2 divided by Q1, right? So let's substitute the values that are given to us. So E1 is 360, then times Q2 is 120. Of course, this is microfarad, and it means times 10 raised to power minus 6. So you'll be having times 10 raised to power minus 6 over, so you'll be having 50 also times 10 raised to power minus 6. Okay, so the 2 times 10 raised to power minus 6, they will cancel out. So 0, we take out 0 from the 120. 5 here is going to give us 1. And 5 here is going to give us 72. So that will be having 72 times 12, okay? And that will be equals to 864 Newton per coulomb, okay? So the electric field strength due to the charge Q2 is equals to 864 Newton per coulomb. So let's return back to the screen to pick the correct answer to this question, and that is option A, 864 Newton per coulomb. Question 22. The energy E of a photon and its wavelength are related by E lambda is equals to X. The numerical value of S is, so we are asked to take H, which is Planck constant, to be equals to 6.63 times 10 raised to power minus 34 joules seconds, and C to be equals to 3 times 10 raised to power 8 meter per second square. So let's move over to the board to provide answer to this question. So we are given that E lambda is equals to X, right? But remember that E is equals to H frequency. Okay, so we are going to replace E with H frequency here, so that we'll be having H frequency lambda is equals to X. But remember that F is equals to C all over lambda. Okay, F is equals to C all over lambda. Okay, so let's go back to the relationship. F is equals to F lambda, and here we want to replace F. Okay, so if we are to replace F, then we'll be having F to be equals to V or C all over lambda. Okay, basically they are the same here. So that H, then we'll be having C over lambda, then times lambda, which is the second lambda, is equals to X. Okay, so lambda can cancel out lambda, so that S is equals to HC. Okay, so in this question we are given C to be equals to, okay, we are given the Planck constant to be equals to 6.63 times 10 raised to power minus 34, okay, then times, we are giving C, which is speed of light in vacuum, to be equals to 3 times 10 raised to power 8. Okay, so we can multiply. So if we add these two, we'll be having 19.89. Okay, so if we apply the law of indices here, we'll be having times 10 raised to power minus 26. Right? Now, if we move this one place to our left, we are going to add 1 to this. So that at the end of the day, we'll be having 1.989 times 10 raised to power minus 25. Okay? So putting this value into 2 decimal places, we'll be having 1.99 times 10 raised to power minus 25. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option D, 1.99 times 10 raised to power minus 25. Question 23. The bond that forms a semiconductor is A, covalent, B, electrovalent, and C, ionic, and D, metallic. Okay, so the bond that forms a semiconductor is actually covalent bond. Okay, so covalent bond exists between semiconductors such as silicon, germanium, etc. exhibit covalent bonding. Okay, where atoms share electrons to form a stable structure. So that makes option A the correct answer to this question. While for the rest option, electrovalent and ionic bond, basically they are the same. And for option D, metallic bond is common to metals. Okay, but the answer to this question is option A, and that is the bond, okay, that forms a semiconductor. Question 24. Silicon doped with aluminium and germanium doped with arsenic becomes, so A, we have P and N types respectively. B, we have N and P type respectively. While C, we have P type semiconductor, and D, we have N type semiconductor. So basically, one thing we must note is that silicon is a tetravalent element, okay, meaning that it has 4 electrons on its atomos share, while aluminium is a trivalent element, meaning that it has 3 electrons on its atomos share. Okay, so dope means to add. So when silicon is doped, or when aluminium is added to silicon, what happens is that the 3 electrons from the aluminium will combine with 3 electrons from silicon, leaving 1 electron. Okay, leaving 1 electron, and also creating, so, and that will lead to the creation of holes, okay, on the semiconductor material. Now that hole that is created now becomes the charge carrier, okay, leading to the production of P-type semiconductor. Okay, now for germanium, which is also a semiconductor, has 4 electrons on its atomos shares. Okay, and arsenic has 5 electrons on each atomos share. So when germanium is doped with arsenic, okay, 5 electrons from the arsenic will combine, okay, will bond to 4 electrons from the germanium, okay, leaving 1 electron vacant. Okay, so that 1 electron is free to move about, which becomes the charge carrier in the semiconductor, and that leads to the production of N-type semiconductor. Okay, so when a silver is doped with aluminium, a P-type semiconductor is formed, and when a germanium is doped with an arsenic, then an N-type semiconductor is formed. So that makes option A the correct answer to this question, P and N type respectively. Question 25. The figure above shows 4 forces, 3 Newton, 10 Newton, 3 root 3 Newton, and 6 Newton acting on a particle P. The resultant of the 4 forces is, so let's move over to the board to solve for the resultant of the 4 forces. So to do this, we have to resolve the forces into their x and y components. Okay, so let's take draw a table. So here will be for the forces. So the first force that was mentioned there is 3 Newton, then we'll have the 10 Newton, then we'll have the 3 root 3 Newton, and the last one is 6 Newton. Okay, so let's take here to be for the S component and here to be for the Y component. Okay, so we have to resolve these forces into the X and Y component. So the angle for the N forces, okay, for the 3 Newton force is actually 0. So here we'll be having 3 cos cos 0, okay, and that will be equals to 3 Newton, right? So here we'll be having 3 sine 0, and that will be equals to 0 Newton. Okay, so we'll move on to the second one, which is the 10 Newton force, and that one is inclined at an angle 30 with the horizontal. So here we'll be having 10 cos 30, and that will be equals to 10 times root 3 all over 2. Okay, cos 30 is one of those special angles. Okay, so cos 30 is actually equals to root 3 all over 2. Okay, so at the end of the day, this will give us 5 root 3 Newton. Okay, so here we'll be having 10 sine 30. Remember, sine 30 is 1 over 2. So here we'll be having 5 Newton. Okay, now the 3 root 3 force is inclined at 90 degrees. Okay, so here we'll be having 3 root 3 cos 90 degrees, and this will be equals to 0 because cos 90 is actually equals to 0. Okay, while here we'll be having 3 root 3 then sine 90, and that will be equals to 3 root 3, and the reason is because sine 90 is equals to 1, so 1 times 3 root 3 is 3 root 3 Newton. Okay, so the last but not the least, now if you look at the 6 Newton force, is actually inclined in the negative direction for x, on the negative side of x, and also on the negative side of y. So in that case, we are going to be including the negative sign, okay, the minus sign. So here we'll be having minus 6, and it's actually inclined at angle 60. So here we'll be having minus 6, then cos 60 degrees. But remember that cos 60 degrees is the same thing as 1 over 2. So that at the end of the day, we'll be having minus 3 Newton here. Okay. While for here, we'll be having minus 6, okay, sine 60 degrees, right? And remember, sine 60 degrees is equals to root 3 all over 2. So that at the end of the day, we'll be having minus 3 root 3. Okay, I said sine 60 is root 3 all over 2. So root 3 all over 2 times minus 6. 2 here is 1, 2 here is 3. So that's what gave us this. Okay, so let's add. So if we sum up everything, you'll find out that this is going to cancel out this, because this is positive and this is negative. So if we add it together, since the two values are the same, that will be equals to 0. So we have 5 root 3 Newton left as the total for the x component, while for the y component, so we have minus 3 root 3 here, and here we also have 3 root 3. So if we add them together, they will go, so that the total here is now equals to 5 Newton. Okay, but we are calculating for the resultant force. So for the resultant force will be the square root of the square, okay, of the force that we obtain from the y-axis, then plus the square of the force that we obtain from the y-axis. So that resultant R is equals to root, then 5 root 3 in bracket raised to power 2, then plus 5 raised to power 2. Okay, so this raised to power 2 is going to cancel this out, but it's going to square this, so that we'll be having 25 times 3, and that will be equals to, so we still have our root sign, that will be equals to 75, and 5 square is going to give us 5. Okay, so you'll be having 75 plus 25, and 75 plus 25 is equals to 100. Okay, and the square root of 100 is equals to 10 Newton. Okay, so that the resultant of the forces, of the 4 forces, is equals to 10 Newton. So that is just how to resolve forces and get the resultant. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option C, 10 Newton. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos.